move on with the notes. So on Tuesday, if you can recall very well, we definitely talked about the center of the circle, which is the midpoint that is equidistant so from, all sides of the circle. So the midpoints here are going to be K. And then the radius is the distance from the center towards any part of the circle. So we have this KL. Even though the question says give an example, so we're gonna give more than that, okay, more than one. Even give an example, but we need to give more than that. So okay, we have KL. Another radius here is JK, and another one is KI. You only need to move from the center towards the side. And then a chord is just, by joining 2 points on the circle, So if I have this point J and L, the line segment J and L, joining them together gives me a chord. So I have J, L. Joining H and I also gives me a chord, HI. And another chord is definitely from J to I, because J is on the circle, I is on the circle, even though it's a diameter. So JI is also a chord. And the diameter is definitely the longest chord, and it passes through the center. So I'm going to draw a chord that passes through the center, and that's what we call the diameter, JI. It's a chord and also the diameter. And a secant is a line that passes through the circle. So as you can see, this line passes through the circle. So it's a secant, JI. As you guys, one side passes through the circle, the other side stay on the circle. Still, it's a secant, okay? So that's the difference here. And then we only have one tangent. The tangent line is the line that outside the circle and touches the circle at exactly one position. So if I trace this one touches the circle here. So this is called a tangent. So GJ. So GJ is a tangent line. And lastly, we talked about point of tangency. That's the point at which the circle, the tangent line touches the circle. So here J is a point of tangency. And in terms of arcs, we have many of them here. So you're just gonna take few. Here we have a minor arc is an arc that is less than 180 degree, or that is less than half of the circle. So one of them is HI. To represent an arc, always put a cap. And we also have this as a minor arc, IL. We also have JL, JH. So I'm gonna put the 3 dots to show that we have many of them. And a major arc is an arc that is more than 180 degree, or an arc that is more than half of the circle. So here, if I join J and I move around until I reach L, as you can see, the pink motion I just did is more than half of this circle. So this becomes a major arc. But the difference between the J, I move from J to L. If I write JL, it might represent the JL below here, or the JL, the pink I did. So in order to show that it's the pink I'm talking about, I need to put any of these 2 points in between, either H or I. So it's gonna be J, H, and then L. To say I move from J to H and then to L. Or I could have put J to I and then L. So it's the same thing. So we have many of them. And then semicircle is just half of the circle. So if you trace the diagonal, the diameter JI, you take any part of JI, any of the JIs, for definitely form a, which color can I pick? Okay, if I pick this color, so if I trace this guy here, this is a semicircle, so JI. So any of the JI works here is either you put H in between or you put L in between to show that the one below. So it doesn't really matter. So if I put JI, we should be able to know that this is what I'm talking about. But let me put H just as to distinguish what we're really talking about. JHI. Then central angle, it's an angle that is formed when you join two radii. So this is a radius, this is a radius, joining them there together, this is a central angle. Okay, so here too we have, so I'm gonna move from, the red line moves from from I to K. This represents angle symbol, I, K, and then back to L here. So this is the central angle. Inscribed angle is an angle that is, that is formed by joining two chords. So if I decide to take this chord, this radius as a chord, and then this chord here, because the vertex of an inscribed angle is always on the circle, see, and then as you can see, J is on the circle here. So it's gonna be I to J and then to L. So this is just to quickly recall what we did on Monday and Tuesday. Then the major business of today would definitely be inscribed angles. How do we show inscribed angles? We show inscribed angles by just trying to put the vertex at the center, on the circle. So remember, the measure of a central angle is definitely equal. As on Tuesday, we talked about central angle and the arc that is formed across. And we said that the measure of the central angle is equal to the arc that intercepts it. So here, I'm gonna draw such. If I put a point here, call it A. I put another point here, I'll call it B. And then I join the 2 points to the center of the circle, C. So here, this is the arc that is formed across. And then if this arc is 80 degrees, that means the central angle here is definitely 80 degrees. We've seen something like this yesterday during, our quizzes assignments. Then the question that should be asked is that what happened to the measure of the angle if the vertex moves away from the center of the circle? So I'm gonna draw another angle. I'm gonna put a point far away here that will be on the circle, and I'll call it D. And then I'm gonna make sure I draw a chord that goes through A and D, that goes from A to D, and also another chord that moves from D to B. So what do we observe here? As we can see, as C moves towards D, this angle here and 80 degrees becomes smaller. If you move C here, let me just do something visuals. If I move C here, you see the angle becomes smaller. If I move C here, the angle becomes smaller. And when C goes to D, the angle becomes even obviously smaller than the 80 degree we have there. So here, I'm gonna come back. We remember that an inscribed angle is an angle whose vertex is on the circle and whose sides are definitely chords. As you can see, D is on the circle, and D forms an inscribed angle, and the sides of D are definitely chords, AD to BD, AD and BD. Then how do you think an inscribed angle relates to its intercepted arc? So here we have it. We're going to go back to a basic definition. So if you have an inscribed angle, the measure of an inscribed angle is definitely half of the intercepted arc. So which means this angle here is gonna be, what is half of 80? 40. So if you have an inscribed angle, the intersected arc is always twice the angle that is inscribed, which means if I have my circle this way, I have an angle that is inscribed, and this angle is 30. Definitely the arc that is formed here gonna be twice the inscribed angle. So 2 times 30, which is 60. So this arc gonna be 60. But if I have a central angle here, that central angle would definitely be the same as the arc. We're gonna find a relationship between inscribed angle and central angle. Inscribed angle is half of central angle, or central angle is twice inscribed angle. As you can see, central angle being 60, inscribed is 30. Central being 80, inscribed is 40. And the number goes on like that. So, but I'm not going to compare inscribed to center right now. I'm just going to compare inscribed to the intersected arc. So here, the definition going to be the measure of an inscribed angle is half the measure of its intersected arc, which means this is an intersected arc. If it's 50 degree, that this is an inscribed angle. If it is 50 degree, that means the angle that is formed here, the arc that is formed here, AC, will be twice that angle down there. So 2 times 50 is 100. So I'm gonna write a global formula to say the measure of angle ABC is equal to half of measure of the arc AC, isn't it? Because ABC is 50, and then if you do half times AC here, the arc AC is 100. 100 divided by 2 is 50. So the measure of an inscribed angle is half of the intersected arc. In terms of central angle, the measure of central angle is equal to the measure of the intersected arc. But the measure of inscribed angle is half of the intersected arc. So that was the basic thing to learn today. Then we're going to quickly solve these problems and then go back to the homework and stop it there. Who sent a message? Okay, Tyler, welcome. I knew you don't come, you're always present, so I was a bit doubting why you're not coming early today. Okay, no problem. So which means arc equals twice angle. 2 times angle. This is not division symbol. And the other way is angle is half arc. So here we want to find the measure of angle T, this angle T here. And we know the intersected arc here is 48. And the T is an inscribed angle, so it's going to be half of the intersected arc. So what is half of 48? 24. We also want to find the measure of arc QT. So this is angle, so angle arc QT. So let me change color. Q to T. Since the inscribed angle here is 50, then QT has to be twice that inscribed angle. So you're gonna do 50 times 2. And then which gives us 100. So it means this guy has to be 100, and then this guy has to be 24. The next problem, the information we have at hand is that this intersected arc is 62, and we want to find the measure of WXY. So this is inscribed angle. We know inscribed angle is always half of the intersected arc. Since the intersected arc is 62, 62 divided by 2, which is 31. So this angle becomes 31. Also, it's always, if you want to do this kind of thing, make sure you always show that this is the arc, so as not to be confused. Direct your arrow towards the arc far away from the inscribed angle. The next problem, we're looking for DG. We know this angle, this is an inscribed angle because all the sides, all the vertices are on the circle. Then the intersected arc gonna be this, because this angle is from D then to F, DEF. And far away from this angle is this intersected arc. And we know that intersected arc is always twice the inscribed angle. So the inscribed angle will be 113 multiplied by 2. And that gives us 2 times 3, 6, 2 times 1, 2, 2 times 1, 2, 2 to 6. So which means this guy here is 2 to 6. Down here too, we have our inscribed angle to be 42, and far away is this intersected arc. And we are asked to find BC. We want to find BC, but we don't have information about AC. But what we know is that AC is twice this angle here, the inscribed angle. So I'm going to do 47 times 2, which is 94. That means this angle here is 94. So I wrote 49. And this is the guy I'm looking for, this arc here. But what I know is that the red, the purple plus the gray, the blue, the purple plus the red add up to 180. Okay. And then if the purple plus the red add up to 180, and I'm looking for the purple, what do? I'm going to do 180 minus the purple, which is 94. And 180 minus 94 gives me 86. So which means the missing angle here is definitely 86. Because 94 plus 86 add up to 180, okay? Since why? Because BA is a diagonal, And if you have half of a half of a circle is always 180 degree. The next problem here, we have a lot of information. We know this arc to be 65. We also know this arc to be 53, but we don't know this big arc, what it is, J to L. But we know the three of them add up to 360. So what do? We're gonna first of all do 360 minus the two guys we know, the red and the purple. Then if you put this in your calculator, you're gonna have 242 degrees. So which means this arc JML is 242 degrees. But what are we looking for? The question now says find angle JKL. The angle JKL is nothing but this angle from J to K, from J to K and L is this angle here. And this angle here is an inscribed angle, and the intersected arc is 242, which means we're gonna do, and we know inscribed angle is always half of intersected arc. So you're gonna do 242 divided by 2 to find the inscribed angle. So 2 divided by 2, 1, 2 divided by 4, 2, 2 divided by 2, 1, 4 divided by 2, 2, 2 divided by 2, 1. So this gives us 121. And another thing to close the note of today is that let me say, if this is A, this is B, this is C, and this is D, this angle here is an inscribed angle, and then the intersected arc is AB. This angle here too is another inscribed angle, and the intersected arc is also AB. Since the two of them are inscribed angle and they have the same intersected arc, as you can see AB, then they are said to be, so they're gonna have the same arc, and then they have to be congruent. Which means if you know the measure of angle 1, the green definitely is the same as the red, angle 2. So here, we're gonna quickly solve this problem to close it there. We have this arc here, AB, to be 124. And then the question asked here is to find a measure of angle ADB. ADB has intersected arc that is AB, because if I trace A to D and then to B, the intersected arc is AB, which is 124. Then the angle ADB gonna be half of the intersected arc, 124 divided by 2, 4 divided by 2, 2, 2 divided by 2, 1, and then extra making 62. Since 1 cannot go, so 12 divided by 2, 6. So it means ADB has to be 62. And the next angle says AC, I'm gonna move from A to C and then C to B, ACB. And what do you observe here? The intersected arc is also AB. So you don't have to do any calculation again, since you know the red angle to be 62, then the green angle to gonna be 62, because we say when we have two intersected arc with the same endpoint, then they're gonna be congruent. So if two inscribed angles intersect the same arc, then they are congruent. So here this is 62, and then this is 62 as well. So these are things we needed to do today. Take home today is that in terms of inscribed angle, the inscribed angle is formed by taking two chords, and the vertex is always on the circle, and it's always half of the intersected arc, or the intersected arc is always twice the inscribed angle. And another thing is that when two inscribed angle have the same arc, then it means if they have the same intersected arc, then they're going to be congruent. So as you can see in the last problem we solved. So I'm going to stop the recording, and then we're going to go to the homework and stop it there.